Okay, I kind of think that this lesson is oddly named. It says it's graphing linear equations in point slope form, and we really aren't doing that so much as we're writing equations based on their relationship as far as whether they're parallel or perpendicular. So that's what I'm going to focus on here. And I'm going to start off with just some of the special case ones, the horizontal and vertical lines. And so if you remember, I guess if you watched a previous video, I talked about this little acronym HOIVUX to help you kind of remember what horizontal line properties are and what vertical line properties are. So I just pulled this little picture off Google, and a horizontal line has zero slope, and their equations are always y equals. And so your line will cross the y-axis there. That's the HOI part. VUX, that means vertical lines, will have undefined slope, and their equations always look like an x equals. All right, so I'm going to use that to kind of help us do some of these. It says find the equation of the line that passes through the point -1, 5. So that's up here somewhere. It's hard for me to get very accurate on this software, so I apologize for the messiness there. Okay, and it's parallel to the equation x equals 1. So if I come down here, remember x equals is a vertical line. So I'm going to look, it's going to cross the x-axis at 1. So it's a vertical line right through here. Now, they want me to write the equation that is parallel to this one I just draw, this vertical line I did. So if I want it to be parallel, remember that it's not going to intersect, it's going to have that same slope, it's going to be another vertical line. So I want the equation of this vertical line that's going to go through that point that they gave me. Okay, so since it's a vertical line, I know that it's going to be an x equals, and then I look at where does it cross the x-axis, and it crosses at -1. So this is the equation that would go through the point -1, 5, and it ends up being parallel to this one. All right, let's try another one. It says find the equation of the line that passes through the point -2, 6, and it's perpendicular to y equals 2. Y equals 2 is going to be a horizontal line, so it crosses the y-axis here at 2. So this is what they gave me, and typically they actually give that to you in the software. They give you the line that it's supposed to be parallel or perpendicular to, and they give you this other point. And you're just supposed to figure out a specific equation. It says we want the line that passes through this point and is perpendicular. Perpendicular intersects like at a right angle, at a 90-degree angle. So I'm wanting this line right here. So when I look at my line, okay, well that's a vertical line, so it's going to be an x equals, and it crosses the x-axis at -2. So there's the equation I've got. Find the equation of the line that passes through the point 2, -3. So it's going to go through that point, and it's going to be parallel to y equals 4. So parallel to this one. Well, so if parallel means it's going to go at the same angle, so it's going to be another horizontal line. But I want my horizontal line to go through the point they gave me, so it goes through right there. And then I have to write that equation. Since my line this time is horizontal, my equation will be a y equals. And where it crosses the y-axis is at -3. So that's the equation I'm shooting for. Now it's pretty easy when you're talking about horizontal and vertical lines as far as getting that parallel and perpendicular business going, but if it's not, and really most of the time it's not, we have to look at it a different way. So remember that parallel lines means they're never going to intersect, so their slopes are going to have to be the same. It's going to look like something like this and like this, two lines, they never intersect, and so their slope or their slant is going to have to be the same. So you might have an equation like y equals 2/3 x plus 4, and then another equation y equals 2/3 x minus 7. I don't care about those y-intercepts. All I'm really looking at is that those slopes are the same. Okay, perpendicular is a little bit trickier. Perpendicular lines intersect at right angles, and so if you have one line that goes this way, then the other line is going to kind of go this way. and those end up being a nice perpendicular line there. If they're perpendicular, one's going to be tilting right and one's going to be tilting left, and that's going to force those slopes to be opposite. One will have to be a positive, one will have to be a negative. But in addition to that, they also have reciprocal slopes. A reciprocal is when you take a fraction and you flip the numerator and the denominator. So an example of perpendicular slopes would be something like this. One would have a slope of, let's say, 2/3, and then the other would have a slope, well, this one's positive, so my perpendicular line would have a negative slope, and then you flip it, so 3/2. These two slopes would indicate perpendicular lines. Here's another example. Maybe you have -4/5, and then the slope of the line perpendicular to that would have to be a positive 5/4. If you happen to have something like a 7 for your slope, well, remember that that's really 7/1. We don't typically write it as a fraction, but we could, 7/1. So its reciprocal would be 1/7. And we would make it negative since we want them to be opposite reciprocals. Okay, you need to know that for where we're headed. Sometimes they're just wanting you to look at a couple lines and decide, would these lines be parallel, would they be perpendicular, or maybe neither? So what you have to do is you have to identify the slopes of each of the lines and then compare them. So in this first example that I have, I was being really nice because I put them in slope-intercept form for you. And so this right here, remember this is your M, that's your slope. Over here, there's your M, that's your slope. I don't really care anything at all about these y-intercepts when I'm doing this today. All I care about are the slopes. I look at them, they both have a slope of 4. So since their slopes are the same, I would say that these two lines are parallel. All right, on number 2 here, wasn't quite as nice. I didn't give it to you in slope-intercept form. You have to put it in slope-intercept form first. So remember that means to get the y by itself, you're looking for that y equals mx plus b. So I'm going to move the 3x to the other side. So I have negative y equals, remember you want to put your x term first and then your number. And then this is really like a -1 sitting in front of this y, so I'm going to divide by a -1 to get rid of that negative. I don't want that on there. And so then I end up with a y equals 3x minus 4. All I'm really looking at here is the slope. The slope of this one is 3. So then you have to go over to the second equation and do the same thing. Put it in slope-intercept form so you can identify your slope. So I'm going to move my 6x to the other side. So I'm going to have a 2y equals -6x minus 4. Divide everything by 2. That's a little minus sign there, okay. And then you have y equals -3x minus 2. So when I look at this, the slope is -3. Now, once you've identified your two slopes, you have to decide, well, are they the same? And in this case, they are not identical, so I cannot say they're parallel. All right, are they opposite reciprocals? Well, they are opposite. One's positive, one's negative, but they're not reciprocals of one another. One would be a 3 and one would be a 1/3 if I was doing that. So since they're not opposite reciprocals, then that leaves me with a neither. If you end up with something like this, these two lines are not parallel or perpendicular. Okay, let's try another one. Looking at these, we have to put them again in slope-intercept form. So I'm going to move my x to the other side. So y equals -x plus 7. On this side, a little bit more work. I'm going to move my 4x over. I have a -4y equals a -4x plus 10. Divide everything by -4. So then I have y equals, and -4 divided by -4 is just a 1x, or just x. They don't really like you to put that 1 in front of there. And then I could reduce that fraction. 10/4 could reduce, and it's a negative because I'm dividing by a -4 there. So it would reduce to a -5/2. But again, I don't really care about the y-intercept. All I'm really looking at are the slopes. And so on this one on the left, my slope is equal to a -1. The slope on the right here is equal to 1. So then I go through and I have to decide, are these the same slopes? And they're not, so the lines are not going to be parallel. Are they opposite reciprocals? Well, yes, they're opposites. I have one positive and one of them negative. Are they reciprocals? Now this one's a little bit tricky because it's a 1, so that's kind of why I chose this one. Earlier when I had the 3 and -3, those are not reciprocals of one another. But if you think about this, a -1/1, if I flip it, it's still going to be a 1/1. So 1 is kind of special in that way. If it was a 3 and a 1/3, those look different, but on the 1, it looks the same. So in this case, they are opposite, and they actually are reciprocals of one another. So this one I would write perpendicular. Now most of your assignment is doing this right here. We're having to write an equation that's parallel or maybe perpendicular to this other line that they give you. So when they have a problem like this one, write the equation of the line that is parallel to this given line. Now there's this whole line here, and it's really tempting to use a lot of this, but the only thing I want from this line is the slope, because the slope of this line is -1/2. So if I want the equation of a line that's going to be parallel to that, that means I want it to have the same slope. So I'm going to want my slope to also be -1/2. The +2/5 doesn't matter to me because I only just want it to be parallel. And then I want it to pass through the point 6, -4. So this goes back to what we had done earlier, where we have to write the equation of the line when you know the point and the slope. So we're going to use point-slope form. Remember, point slope is y minus y1 equals m times x minus x1. So I'm going to plug in then leave your first y there, subtract the y from your point, equals your slope, it's -1/2, leave your first x, subtract the x from your point. Okay, change that to plus there, and I'm going to distribute my -1/2. So that's going to be a -1/2 x, and a -1/2 times a -6. If it helps you put the 6 over 1, you're going to multiply those straight across. Negative times a negative will be a positive 6/2. But 6/2 reduces, so we don't want to leave it 6/2. It actually comes out very nice. That's just going to reduce to a 3. All right, then move your 4 to the other side, and your equation y equals -1/2 x minus 1. Notice that your equation has absolutely nothing to do with this 2/5 here. Try to ignore that. The only thing you're using that line for is its slope. All right, let's try another one. On this one, we're going to write the equation of the line that's perpendicular to this given line. So again, the only thing I'm interested in is this slope. But since this one's going to be perpendicular, I don't want the slope to be the same. I want the slope to be its opposite reciprocal. So since the slope is positive, mine will be negative. And I flip that fraction, so it's going to be a 5/2. That's the slope I want. And then I also want it to pass through this point, -3, 4. So I go back and do, since I have a point and I have the slope, it sets up beautifully for point-slope form. And let's leave the first y minus the y from our point. Put in the m, or the slope, and then we have x minus -3. First step here is going to be to go ahead and distribute the 5/2. Now this one doesn't come out quite as nice. I am going to do a plus there. That's going to turn into x plus 3. So when I distribute that -5/2, I just write -5/2 x, and then think of that as a 3 over 1. So when I multiply, I'm taking a negative times a positive, so that's going to be a negative, and multiply straight across. So the 5 times the 3 gets me a 15. 2 times the 1 is a 2. And this one is not going to reduce nice for me, so I'll leave it. Add 4 to the other side. Now remember that you kind of have to, when you add these, you got to think of this as a 4 over 1 because you're going to want to add these fractions, except that you need them to have a common denominator. So I'm going to change this. I need the denominator to be a 2. So 1 times 2 would get me a 2. 4 times 2 would get me an 8. So there's my 8 halves, which is the same as 4 over 1, but now these are like, they have common denominators, so I can combine them. So then my equation is going to end up being y equals, the 4 is canceled out, equals negative 5 halves x, and then I have a negative 15 halves with a plus 8 halves. That's going to end up giving me a negative 7 halves. There's your equation. So what happens when they're not quite as nice and they don't put it in slope-intercept form for you? Like on this one, it says write the equation of the line that's parallel to this line. Well, it's not in slope-intercept form, so I don't know what its slope is. So we just have a little bit of work to do. Let's subtract the 2x, and let's get this thing put into slope-intercept form. Divide by the 3. So this equation is a y equals negative 2/3 x plus 14/3. Now, I don't care about the 14/3. All I really want is the slope here. Now, so the slope of that line is negative 2/3. I want the equation that's parallel to that. So if I want it parallel, that means I want to have the same slope. So the slope is going to be negative 2/3, and it's going to pass through the point 1, negative 5. So now you go back, and since you have the point and the slope, you're going to do point slope form. I know there's a lot of forms to keep track of on these. It just takes some practice, and doing several problems just gets you used to which form you're supposed to be using at which time. So be sure you're doing those practice problems. So this will be y minus the y value of my point equals negative 2/3, and then x minus the x value of my point. Change that to plus plus. Distribute your negative 2/3. That's going to become a plus 2/3. And then move your 5 to the other side. Now, again, here you have this issue with these fractions, and so think of this as a negative 5 over 1. But then you're going to want that to have a common denominator, so take the 1 times 3 to get it to be a thirds. But you also have to take your numerator times 3, so it's going to be a negative 15/3. Okay, so now these are common denominators, so they can be combined, and I have a positive 2/3, a negative 15/3 would give me a negative 13/3. And there's our equation. All right, so I'm going to go through one more kind of like this. If you feel good, go ahead, you can quit, but I've got one more to try. On this last example, it says write the equation of the line that's perpendicular to this given line. Okay, so if it's going to be perpendicular, I want it to have opposite reciprocal slope. So let's go find the slope of this equation. I'm going to have to subtract the x on both sides. Negative 3y equals negative x plus 7. Divide everything by negative 3. So then y equals, this is like a negative 1x right here, so negative 1 divided by negative 3 would be a positive 1/3 x. And then I'm going to have a 7 divided by negative 3, so it's going to be a minus 7/3. Don't care about the 7/3, all I'm looking at is the slope. The slope of this line is 1/3, so I want the slope that would be perpendicular to that. So I would want the opposite reciprocal. Since this one's positive, mine's going to be negative, and I flip the fraction, so that'd be 3/1, which really would just be -3 then. And so that works out nicely. So I've got my slope and I've got my point. So let's go put it into point slope form. Okay, leave the first y, subtract the y from your point, equals, your slope is now going to be a -3. Leave the first x, subtract the x from the point, change those to plus plus, and let's distribute that -3. So -3x minus 6, move the 8 to the other side. And so here's my equation. It's going to be perpendicular to the one they gave me. It's going to go through the point -2, -8. All right, hope this helps.